Hey, TechKnowStuds! Storage is a critical part of your computer, and you need to know a few things about storage. So we're going to hit some of the highlights in this lesson when it comes to storage. Storage is a critical role in how your computer functions. That is, before anything gets processed, it goes through storage first in RAM. And it also needs instructions on how it's going to operate. The initial set of instructions come from storage. Of course, it needs a whole operating system, which is stored in storage. Need to save something? That's saved in storage. So storage plays a critical role in how your computer operates. So we're going to talk about characteristics. Characteristics is how these things perform and act. For instance, is it volatile or non-volatile? We're going to talk about the media, what exactly it's stored on. So this is an example of magnetic media. So what is it being stored on, and what is the technology that we actually store this stuff on? Or what type of component it is. If it's a component of a computer, like a solid state drive, it goes into the computer and it's part of how a computer functions. If it's a form factor, it's how these things are shaped and the size of them. And so what is the form factor of that? If it's the protocol or interface, is how does this communicate and how does it interface with the computer? And so there's some signaling and different types of signals that happen with here. And so these are explaining all different aspects of storage. Now, this is an incomplete list in each one of these categories. There's actually a lot more: media, components, form factors, characteristics. There's a lot more, but I've created this table to help clarify some things. There's a little bit of confusion when it comes to these different ideas. For instance, ROM. And the reason why it gets confusing is because ROM is a characteristic. ROM is read-only memory. So it's the type of storage we have. For instance, we could have a CD-ROM, which is a media here. But not only is it a characteristic that we have, it's also a component in a computer. We have ROM on our computer, and it's an actual part of the computer. So that gets a little confusing. Solid-state drives are a type of storage or a component on our computer, but it has the term solid state in it. And really, all of these components that I'm showing you right here are solid state components. It also can be volatile or non-volatile. It also, with a solid state drive, has different form factors. It can come in very different shapes and sizes. And it also could come in any one of these different protocols or interfaces. When we think of flash, we think about a flash drive. But flash is just a type of solid state right here. So flash is a type of solid state, and there's actually a lot of other examples, although flash is one of the really prevalent ones that are out there. Solid state drives use flash as well. And so the same circuitry and the same type of technology that's in here is in most of our solid state drives as well. And so we can see these overlapping themes that come through all of these different characteristics, media, components, form factors, and protocols and interfaces. Storage really falls into two different types of categories. It's either volatile or non-volatile. Volatile means that it needs a constant source of power in order to save that information. So an example of it is like RAM. As soon as we turn the computer off, that memory goes away, and we start all over when we turn the computer back on. And so that would be an example of volatile memory. Versus non-volatile means that it doesn't need power to keep the settings, that it stores it long term, and so we have some stability with it. One of those non-volatile memories would be read-only memory. So an example is this is a DVD. There are some DVDs that you can read and write to, but this one you cannot. You can only read from it. So it's a read-only memory CD-ROM, or the DVD. Since it's a movie, this is actually a DVD. So this is an example of read-only memory. But there's also a computer component that we refer to as being the ROM. And so where that lies is it plays a part in the whole BIOS, or the BIOS is actually part of the ROM. And so what we have is we have semiconductors, actual chips, physical chips on the board that carry these instructions, which is the BIOS, carries the BIOS that holds that information, and it's really designed to just be read from, and really not really designed to be written to. And so we've got that ROM on the motherboard, and so when the computer starts up, then that BIOS gets loaded into RAM, so that way it can provide that initial set of instructions. So the hardware that does that we call the ROM. ROM is an example of local storage. So there is several different local storage aspects to this. We have the ROM, of course, which we just talked about. We have RAM, which RAM is that what is staged before it goes into the CPU, or what holds information that what comes out of the CPU before it goes out to all the other components. So that's the RAM. And then we have the just storage drives that are on the computer. So an example here might be a floppy or disk drive, or it could be a solid state drive. So those are some examples of storage drives that are on your machine. Here's a motherboard. Let's talk about some of the different storage devices on this motherboard. So one, we have our RAM right here. This is our random access memory, and that's the direct connection. Things get loaded up on here before they get sent to the processor, and then things that come out of the processor can be sent back to here before it gets sent back out to where it needs to go. So there's that. We also have our storage. So this is our SSD right here, and we could plug that into one of these SATA ports. So now we can have our storage where we're storing our files and our operating system. So we have that right there. Another thing we have right here is our ROM. And I'm not 100% sure that this is the ROM chip, but I'm pretty sure it is because it's close to the battery. The battery is to keep those BIOS settings. So here is our ROM right there, is the way we believe that is. Now, a couple things that we have also on here. There is some memory built into the CPU. And so depending on what size of CPU and the generation it is and everything, you'll have different amounts of memory on there within the CPU as it's processing things. Another thing to point out too is here I have a NVMe, which is one of the technologies or one of the standards that have replaced our older solid state drives. Now, this connection looks very different than these PCI connections that we have right here. These PCIe connections. It looks different, but it's the same type of connection, just the pinout's different, and this is an older motherboard, so it doesn't have the one that can interface with this, but it is the same type of technology that they're using for these PCIes. So that is a newer type of solid state drive, a replacement for this solid state drive. Here are some examples of solid state drives. They all use solid state. So here on the far right, we see a USB flash drive and it's got a chip on it. I can peel that back, the sticker on here, and we see a similar chip on here. We peel back the sticker on this one, and we could see on it similar chips on it as well. So, and then finally, we have this drive right here. If I were to open it up, it would look like that on the inside. So we have chips on there. So we would consider all of these solid state. And now what are the differences? Well, first of all, this is a flash drive. So typically we wouldn't hear this referred to as a solid state drive. We would refer to it as a flash drive. Although quite honestly, all of these probably have that same flash technology built into it. Flash is just the main technology we use for these semiconductors for the solid state storage. So this is a flash drive, and it's really the only one that we would be referred to as a flash drive. I guess one of the exceptions is the SSD on a Mac is called flash as well. So you'll see in some circumstances, well, the main storage of it is called flash. But for the most part, we just refer to these USB type drives, these USB flash drives, as being the flash drives. So that is a flash drive right there. Okay, what else do we have? Well, we have the solid state drive. And so this is one of the originals that replaced our magnetic drives. So we had magnetic drives in the past, and we replaced it with the solid state drives. So this is the 2.5-inch form factor. At some point in time, we started creating smaller form factors. So right here is an example. It's the same thing, same type of technology, except for this is an M SATA. That's the form factor, the size and the shape of it, versus this would be a M.2 right here. So that's the form factor, the size and the shape. And then how these plug in and connect are different types of technology. So the signaling and the coding that goes back and forth between the computer, this would be SATA right here. This also, since this is M-SATA, this would be SATA as well. But this one is NVMe, so it uses the PCI slots to communicate with the computer. So it's a little different than these others. And NVMe stands for Non-Volatile Memory Express. So that's what the NVMe stands for. Here's some examples of magnetic storage. Here on the far side, I have an audio cassette. Usually we're saving things like songs onto here. However, the first computer I had, I would actually save data to these. So it can store data. And then here we have a floppy disk. So the floppy disk, now it feels like it's not very floppy, but the older version of this that was 5¼ inch was very floppy. And then if you open these up, see this has a little slide, so when it slides into the computer, it exposes the magnetic side of this where it actually stores the data. But let's take this apart and see what's on the inside. And so I'm just going to take that off. And if we look on the inside of this, this is what stores the data, and it is very floppy there. So that is a floppy disk, and this is a 3½ inch floppy disk here. All the data and all the fun I had with those. All right, now this is a hard drive. So it's considered a hard drive mainly because, I mean, it's actually hard. So if we open up on the inside here, we can see that there's this spinning disk. That's the magnetic where it stores the little ones and zeros. And so it's pretty hard. And if you get a bigger one, it'll actually make like a little ting sound like a cymbal. And then this is the reader. So it will swing back and forth and read the ones and zeros on this disk. So that right there is a hard disk. And then here's an example of a tape drive. So this is a backup tape drive here. And so this would come out and then store the little ones and zeros on here. Very similar to what this looks like, except for it's just a little different format. And then store the ones and zeros on here on this tape drive. And then this would be encased in a cassette. And then I would put all these different cassettes into the system, and it would actually store a lot of data. But it was very slow because it actually had to pull this whole thing out and read all of that data, and then it'd have to wind it all back up. So that's some examples of magnetic storage. Here are some examples of an optical drive. So an optical reads DVDs and CDs. And so what we have here is one from a laptop, and this is one from a desktop machine. And I've torn them apart so we can see the insides. Essentially, we would slip the DVD into here, and then it would close up. This is the spindle that would then come up and then read that disc or spin that disc. And then this is the reading head. So a little laser shoots out and will send a laser that will hit they're like little micro bumps that are along the CD. And so that's what would actually send a signal back, and then it would read that signal. So this goes back and forth, and we can see something similar on this laptop one. So it's called optical because it's using visible light in order to read these CDs and DVDs. So hopefully that gives you some insight into these different technologies and how they interplay with each other. We have these different characteristics, this different media, components, form factors, and protocols and interfaces, and there's this certain combinations of these that we use for certain aspects when it comes to storage on your computer.